Okay, so in this video, we're going to plot planes as poles on the stereonet. I've got my tracing paper set up, north, south, east, west, marked off. Here's the 4 planes, just sketching down so we can keep track of them. And the first step in plotting poles to planes is the same as doing great circles. Now, why would you want to plot as poles as opposed to great circles? There's a variety of reasons. The simple one that most people realize after they have, say, 100 planes to plot, plotting as great circles is slower, and it really clutters the stereonet. That's not to say that plotting as great circles isn't useful. It has a variety of uses in specific situations. But if you have lots of data, plotting your planes as poles could be more straightforward to visualize the data with, because the planes are now just a point, not an entire great circle. Okay, first step, as I said, the same. Mark the strike. And again, when you get familiar with this, you realize that when you're plotting poles, you can then rotate the strike to any cardinal direction, and you should be able to successfully plot it from there. When doing great circles, you have to go north to south, and then, as I always say, the safe bet is you don't know where to put your compass direction, just put it to north, and it should always work from there. So the first one, I will put it to north, right? Because we want to follow, what are we going to do? North 56 is now at north, 23 southeast. Now, if you're doing a great circle, you would start from the southeast side and count in 23. Well, we have to think about what is the pole to a plane. Here's a plane, there's the pole or the perpendicular to it, that's 90 degrees. So we have to count the dip and then go another 90. Now, we can do that, count 23 and then add 90. The quick solution would be you would start at the center of the stereonet and then count 23 along, again, east-west line, because we put the strike at north, 23 degrees from the center. And so I'll do it kind of the long way, right? I would go 23, 10, 23, and then I would go 90, which would be the same as starting here and going 23 this way. 10, 23, and then the pole is just a dot, a point on the stereonet. And then we would rotate north back up to north, and then we've successfully plotted that. Now, this is what's always confusing, is that the pole plots in the quadrant opposite of the dip direction. So this is a southeast dip. The great circle should be going like this, around this way. The pole is perpendicular to that, so it plots over here and it's opposite. And then the other thing that's opposite is when we were doing great circles, things that are low dip, the great circles would be around on the outside. But if you're low dip, the pole is then towards the center of the stereonet, and then high dip, right, poles are going to be towards the outside of the stereonet. So both those things are opposite in terms of where the point plots in quadrant of the dip, and then steep things being in the center or the outside. Okay, let's do the next one. South 52 east, 67 northeast. There. You can see there's the pole to South 52 east, 67 northeast. The pole ends up in the opposite quadrant than the dip direction. Next, 193, 88 west. There we can see this is a very steep plane. And as we talked about when we did great circles, it means it's almost going to be a straight line because it's 88 degrees, and 90 would be a straight line through the stereonet. But high dip planes get a pole that's close to the outside because it's 90 degrees away. And so that's plotting up on the edge of that bowl. And then lastly, north 56 west. 02 southwest. This is going to be a situation where I'm going to show you that you can then go to east and west and still plot it successfully, but you got to then use the north-south line to plot the pole. And again, the pole ends up in the opposite quadrant from the dip direction. So I had to take off the eraser puncture protector. Plane's going to be like this, pole's like this because it's low angle. The pole plots very close to the center. And indeed, it is in the northeast quadrant where the dip direction is in the southwest quadrant. Everything is opposite. Okay, so that's how you plot poles on a stereonet.